Hello, everyone. This is Roy Carter, and I'm here today with the first session of the geoscience training. And this is to kick off the CSTEM challenge. And so what we're gonna do to talk about today is first we're gonna go into the CSTEM challenge, and I'm very excited about this year's CSTEM challenge. I think you and your students are gonna learn a lot from this challenge. It's a very interesting challenge. And so, with that said, let's just go ahead and move on to the next. So first off, let's talk about the cycles that we're going to go through because as you can see, the system challenge is going to be in right around like April, middle April. And so right now we have roughly 6 months in order to get you prepared for the system challenge. And so therefore, this is a pacing guide, and so it's designed to kind of guide you through this entire process. And so, one of the things that we're going to do first off is we started off with the CSTEM Challenge kickoff, and that was last week. And so, one of the things that I would suggest you do, if you weren't online for my discussion about what is geoscience and what is some of the careers that are attached to geoscience, I basically gave an overview, and I'm going to quickly go through that overview in the next couple slides. But I would highly recommend that you go back and take a look at the CSTEM Challenge kickoff for the geoscience. But today, what we're going to do is we're going to talk about some of the research that needs to be done in order to successfully complete the geoscience challenge of the CSTEM challenge. And so, as you can see, we're going to go through a number of different steps. And then one of them is, how you see, we're going to design prototypes, construct the prototypes, and doing the artifact solution. But right now, where you and your students should be focused on is really getting the research together in order to successfully complete the geoscience challenge. So, what is geoscience? And then one of the things that you have to remember about geoscience, geo just means earth. That's Latin for earth. And so geoscience is the study of the earth. And so they use a number of different fundamental science, such as physics, chemistry, biology, and mathematics. And what they're trying to do is understand how the earth works as a natural system. And so one of the things and the number of different problems that geoscientists work on, such as climate change, potable water, natural disasters, and also resources. And I also discussed this in greater detail in the previous System Challenge kickoff presentation. And so one of the things that we tell people is that it could be a very rewarding careers in geoscience. It's a very, as you can see, studying the Earth is a very big system. So there's a lot of different aspects of the Earth that you can study, such as everything from anything that surrounds water, whether that's fresh water, hydrology, or you can be study the ocean, an oceanographer, or things such as weather, which is meteorologist or climatologist. And so those are one of the number of different careers that your students could pursue within geoscience. But with that said, let's move on to the actual challenge because this is going to be a very interesting challenge, and I think it's going to be very rewarding for a number of people. And so, if what I'm going to do is I'm going to go through and read the actual challenge overview. And so, therefore, what it's about pipelines. And so the challenge reads building new pipelines and updating existing ones can bring about thousands of jobs to the nation. According to the American Society of Civil Engineers infrastructure report card, the oil pipeline infrastructure is in poor to fair condition and mostly below standard, with many elements approaching the end of their service life. A large portion of the system exhibits significant deterioration. Condition and capacity are of significant concern with strong risk of failure. Students will invent a technology or mechanism from recycled, reused materials, and along with the materials provided in the geoscience kits as a solution to lessen the human carbon footprint. So, therefore, what we're going to talk about this year is oil pipelines. And so, probably a number of you are probably saying, well, what's the big deal? Why are oil pipelines so important? But what we're going to talk about in the next few slides is why this is actually a very interesting and very fundamental, going to be a very interesting project for you to study this year. And so, as the challenge is stated, this is going to be about oil pipelines. And so, just a little bit about my background. I work for Chevron. And so, Chevron is an exploration and production company. So, what we do is we extract oil and gas from underneath the ground. And so what we have here is a schematic, a diagram, and then what we do is we take that oil and gas that we extract from underneath the ground, and then we ship it using pipelines to refineries. And so that's a very simplistic view. But what we're going to do today is talk in detail about how pipelines are essential to how the oil and gas business operates. So therefore, in order to understand how the oil and gas business operates, you first need to understand how we extract oil and natural gas from underneath the ground. And so, as you can see from the diagram here, we have a rig, and that rig drills underneath the ground. And so it can drill a number of different ways. It could drill vertically, or it can drill off to a slant, or it can even drill horizontally. And so just an aside, a quick aside, that a number of you have probably heard about horizontal drilling and fracking. And so that's what happens is that a drill can drill horizontally for a number of distance, literally like 2 miles from where the rig is standing. And so what it does is it drills underneath the ground and it goes to the reservoir. And so a reservoir underground that contains the hydrocarbons. Then those hydrocarbons, think of it as a straw. And those hydrocarbons are sucked up to the surface of the ground. And then where pipelines come in, typically the oil fields are a long way away from from where the refineries are. And so pipelines are used to ship that oil from one place to another. Okay, so let's talk about pipelines. What are pipelines, first off? Okay, so as I said before, pipelines are used to transport materials from one point to another. And some of you, we're talking about oil pipelines, but really pipelines are used to transport a number of different materials that we use every day, such as natural gas and water, gasoline, and even sewage. Your sewage system is piped using pipelines. Okay, so why pipelines? What's the big deal about pipelines? Well, first off, you have to understand that in order to transport materials long distance it can be very expensive. Okay, first off, how are you going to take that substance and transport it across a long distance? You can either use a train or a truck. But the problem with that is that typically you can have a vehicular accident. And so if you have a vehicular accident, then you could potentially have oil and gas, big major oil and gas spill all over your roads. And so it's actually safer to use pipelines to transport this material from one place to another. Because what happens typically, and also from a global warming, like environmental point of view, it's much more energy efficient to pipe that material from one place to another than it is to ship it using either trains or trucks or ships. And so another thing that I want you to realize is that it's also very durable. Pipelines can last, are designed since they're built from steel and they're buried underground. They can last a long time, literally like decades and decades. As you can see at the left, we have a picture of the Alaska pipeline, which was built in Alaska from the North Slope of Alaska down to the southern part of the state. And that pipeline has actually been in service. I believe it was built in the early 70s and is still in service now. So as you see, these pipelines last a long time and they're safe, much safer than actually shipping them from using trains or trucks. And then another interesting thing about this is that there's hundreds of thousands of miles of oil pipelines in the United States. But the interesting thing also is that there's literally like 10 times more gas pipelines. And so if you think about this, the reason that is because gas pipelines, like everybody here probably has a gas pipeline that goes into their house, whereas you don't necessarily have an oil pipeline that goes into your house. So typically gas is distributed using a big trunk pipeline, and then it's little bitty pipelines that go into individual houses. That's why there's so many different gas pipelines, whereas petroleum or liquid-based petroleum products tend to be sold at distribution centers such as gas stations. And so that's why you need much less pipelines. But one of the cons of pipelines is that, as you can see, since they do cover long distances, they tend to be pretty expensive to build. and you need a lot of the lead time because you have to get a lot of permits and right of ways in order to actually build the pipeline. And then another big problem is that, well, another problem, but even though it is a safer way to transport materials, pipelines do rupture. And then if a pipeline ruptures, it can spill significant volumes of hydrocarbons, which need to be cleaned up. Okay, so why do we need pipelines? Why is this important? And as I said before, we go from the field to the refinery to the market. So think of the field as the place where we actually produce that oil. And so what happens is the pipeline there's a gathering system that brings the that brings the oil from all the different surrounding fields to a central located place. And so and then it takes it and then it puts it into what they call these large diameter trunk lines. And so the trunk lines are what go from one point to another. And so think of like the Keystone pipeline. That would be a trunk pipeline because that's going to go from Canada all the way down to Houston. And so once we have the oil that's been collected and placed into the trunk line, then the trunk line carries that oil to the refineries. And remember, the refineries take that crude oil and turn it into petroleum products such as gasoline, diesel, jet fuel, propane. So the things that we actually consume, because we really don't consume crude oil, we consume the products of crude oil. And then after the refinery turns it into those petroleum products, then it's actually piped back out to distribution centers where the product is typically trucked to market. So that's market. So it goes to distribution centers. So think of like your gas station. So what happens is after a refinery takes that crude oil and turns it into gasoline, then that gasoline is shipped to our pipe to a distribution center where it's loaded onto gasoline tankers, and then those tankers take that gasoline to your local gas station, where you drive up to the gas station and then you fill up with that substance, that product. So that's why pipelines are so critical because we have literally billions of gallons of material flowing through the system at all time. And the pipelines make it very efficient to move these billions of gallons of material across the nation, literally across the nation. And so, as you can see here, this is a map of the U.S. pipeline network, and as you can see, it's a very complex network. But one of the things I want to just bring your attention to is that, as you can see, most of the pipelines, as you can see from the blue and the red, are located at the right around. Whoops, excuse me. Right. So most of the pipelines are located right around the Louisiana, Texas, Gulf of Mexico area. And so there's a reason for that, is because if you take a look at so all of the pipelines are coming down there because most of your big oil fields, especially in the past, were located in West Texas area. So the Midland, so as you can see, when the New Mexico Texas border meets, there's a lot of oil and gas pipelines. And so a lot of refineries popped up around the Gulf of Mexico region, and also the Gulf of Mexico is easy to ship is easy to bring in crude oil by ship also, and so that's the reason why there's a lot of refineries down there, and so those products are shipped up to the rest of the nation using a number of major trunk pipelines. And so on the right hand side, you can see the map of the Keystone Pipeline, which is currently under debate. As you can see, it goes from Canada, or the southern part of Canada, down to the Houston area. So there's a number of different refineries down in the Houston, Port Arthur area. So what they want to do is take oil that's produced in Canada and then bring it down to the Gulf of Mexico. But the one of the biggest concerns is, as you can see, they have this thing called the Ogala Aquifer, and so this is a large body of fresh water. And so the biggest concern right now is that if the pipeline ruptures, that oil could potentially get into this aquifer, and this aquifer is essential for agriculture and also drinking water for millions of Americans. Okay, so where are the pipelines? And so the pipelines are actually everywhere. You have you're located, you live next to pipelines. You One of the things that I would like you to do is pay attention next time you're driving. Is that you'll see these pipelines signs all over the place. Actually, if you just kind of pay attention, and so as you can see, the signs are typically in the yellow and black, and so the pipelines are buried 3 to 4 feet underground. And so that's why one of the things that the public always stresses is to be careful whenever you dig somewhere. But always call 811 before you're digging, but especially if you think there's a pipeline that might be present, because if you hit a gas pipeline, that can cause significant damage to you and to people. So with that said, here's a couple of resources for you. These are actually some very good resources in terms of how pipelines work. What we will be doing over the course of the next 6 months is what I'll try to do is give you an overview and also provide you some resources for you to use in order to teach your students. Now, with that said, okay, so it looks like we're at the end of the talk right now. So what I'm going to do is, looks like we have roughly 15 minutes left. So feel free to ask any questions. I'll be around for the next 15 minutes until the session is over with. But also, if you have any specific questions, feel free to reach out to me. My name is Roy Carter, and my email is roycarter@chevron.com. So feel free to reach out to me if you have any direct questions. I look forward to working with all of you over the next few years, and have a good day. Take care. Bye bye.
Hello, everyone, and welcome to Everyone is an Artist and Engineer. CSTEM November 15 training, energy infrastructure, wind, oil, and natural gas, VEX robotics teacher training for elementary. Today's outline is going to be consisting of pairing the VEX Cortex microcontroller and the VEX joystick. We're going to cover some topics of what is pairing, components needed, VEX Cortex explained, VEXNet joystick explained, step-by-step instructions on pairing, option 1 and option 2. What is pairing? Pairing. The joystick must first be paired to the Cortex microcontroller before they work using the VEXNet keys or the USB cable. This process will be completed each time you use a joystick or Cortex with a new mate. A joystick can only communicate with a Cortex that has been paired with. During the pairing process, the ID from the Cortex is transferred to the joystick, thus mating the two units together. Components that you will need for the pairing: a VEX 7.2 volt battery fully charged, 6 AAA rechargeable batteries, a VEXNet ARM Cortex-based microcontroller, a VEXNet joystick, and 2 VEXNet keys. You will also need some motors if you want to test the pairing before you build your robot. And the motor controllers. VEXNet Cortex explained, to give you an idea, what are you looking at? You're looking at the Wi-Fi key in the middle, which is the VEXNet key that we've been talking about, 802.11.g. Transmits the information to the joystick using wireless signals. You can also insert the USB out there in the same area. Going clockwise, you're going to have serial communications for elementary. Don't worry about this. You will be using motors in your kit, so you will only program using ports 2 to 9. So if you want to change a motor port later on in your programming, you got to make sure where you're connecting the motor controller, and then you're attaching the motor to that motor controller. You have to know exactly what port you've inserted the motor into in order to program your robot. By default, once you pair, you're going to have ports 3 and 5 automatically available to run your motors. Battery, 7.2 battery gets inserted here. Digital inputs, do not worry about it. This is for your sensors for middle school and high school students. And analog, if you have analog sensors. A side view of the Cortex. You have the on-off switch, the main power port where it's inserted, backup battery port for Wi-Fi communications in case your battery runs low. It will give you a few minutes to actually communicate with your joystick before it completely dies. Configuration switch for special procedures. Don't worry about this. It will not be used. And also the 7 millihertz crystal, or megahertz, I'm sorry, 75 megahertz crystal interface. It will not be using. These are plugs, plastic plugs that allows you to keep the motors in place. Okay, explain the joystick. You're going to have 8 buttons on the top, 2, 3, 4, 5, 6, 7, 8, 2 XY analog keys. If you take a look at the numbers, you have 1 and 2 on the right, 3 and 4, and when you program these analog joysticks, that's where the numbers you're going to be manipulating in your programming code. Your power switch, 6 AAA batteries get installed under here. You have to remove a small Phillips head screwdriver. And it's also a 3-axis accelerometer built in with this joystick. You have 4 buttons on the front side, and this is your programming interface. We'll talk about it later. And where you plug in your USB key, so the other key will be right underneath here in this portion. For a view of the button status buttons, the first one on top is your joystick. It will followed by the robot battery status. How's your robot doing? This is your Cortex responding to your joystick. and the communication link between the two, if they're being communicated or not. And finally, your game status. A green battery, it's good charge. A yellow battery means it's dying, and when you see any red buttons, that means it's dead. On the communication side, green VexNet COM established, yellow is searching. Lights on the controller and the joystick are the same. They should match the Cortex and the joystick. Pairing instructions. Start by connecting the charged 7.2 volt battery to the Cortex and inserting the key. Add the batteries to the joystick by removing the screw cover and install the batteries. Remove the screw in the middle and insert the batteries. After that, install your VexNet key, as seen here. Add the VexNet keys to the Cortex and joystick controller and power them both. Make sure you turn on the power button on both the joystick and the Cortex. A valid link is as shown. A VexNet light will be blinking a fast screen on both units. The robot light will blink green, be mostly on both units, and when using fully charged batteries. Very important that batteries are fully charged. It will take about 10 to 15 seconds for a link line to be established. The joystick's light will be solid green. So the joystick will turn solid green, the very top one, when fully charged batteries. If it fails, turn off both the Cortex and the joystick and try again. Pairing instructions. Default code is automatically set once everything is paired appropriately. In order to test, you can add either the motors directly, or I would advise the motor controllers and then the motors attached to them. But add the motors and test. Plug the VexNet motors plugged into the motor port 2 and motor port 5. With default code, pushing joysticks channels 3, so this will be up, and this one up, to turn clockwise. Pushing joysticks channel up 2 will cause the motor 5 to turn counterclockwise. And this is the default code. Later on, we'll show you how to change the code. Programming your robot. We'll be programming the robot with RobotC. RobotC is a C-based programming language used in education robotics and for competitions. Using RobotC, you will be able to instruct your robot to carry out tasks autonomously as well as respond to the control inputs. Don't worry about the autonomous response. We will not be using this in this particular competition in this level. On this particular section, we'll meet again December 16th for a question and reflection on this course. Students will question, reflect, and collect resources to design a prototype solution for the problem. Thank you. Hello everyone and welcome to Everyone is an Artist and Engineer CSTEM November 15 training, Energy Infrastructure, Wind, Oil and Natural Gas, VEX Robotics teacher training for elementary. Today's outline is going to be consisting of pairing the VEX Cortex microcontroller and the VEX joystick. We're going to cover some topics of what is pairing, components needed, VEX Cortex explained, VEXNet joystick explained, step-by-step instructions on pairing, option 1 and option 2. What is pairing? Pairing. The joystick must first be paired to the Cortex microcontroller before they work using the VEXNet keys or the USB cable. This process will be completed each time you use a joystick or Cortex with a new mate. A joystick can only communicate with a Cortex that has been paired with. During the pairing process, the ID from the Cortex is transferred to the joystick, thus mating the two units together. Components that you will need for the pairing: a VEX 7.2 volt battery fully charged, 6 AAA rechargeable batteries, a VEXNet ARM Cortex-based microcontroller, a VEXNet joystick, and 2 VEXNet keys. You will also need some motors if you want to test the pairing before you build your robot. And the motor controllers. VEXNet Cortex explained, to give you an idea, what are you looking at? You're looking at the Wi-Fi key in the middle, which is the VEXNet key that we've been talking about, 802.11.g. Transmits the information to the joystick using wireless signals. You can also insert the USB there in the same area. Going clockwise, you're going to have serial communications for elementary. Don't worry about this. You will be using motors in your kit, so you will only program using ports 2 to 9. So if you want to change a motor port later on in your programming, you got to make sure where you're connecting the motor controller, and then you're attaching the motor to that motor controller. You have to know exactly what port you've inserted the motor into in order to program your robot. By default, once you pair, you're going to have ports 3 and 5 automatically available to run your motors. Battery, 7.2 battery gets inserted here. Digital inputs, do not worry about it. This is for your sensors for middle school and high school students. And analog, if you have analog sensors. A side view of the Cortex. You have the on-off switch, the main power port where the battery gets inserted, backup battery port for Wi-Fi communications in case your battery runs low. It will give you a few minutes to actually communicate with your joystick before it completely dies. Configuration switch for special procedures. Don't worry about this. It will not be used. And also the 7 millihertz crystal, or megahertz, I'm sorry, 75 megahertz crystal interface, it will not be using. These are plugs, plastic plugs, that allows you to keep the motors in place. Okay, explain the joystick. You're going to have 8 buttons on the top, 2, 3, 4, 5, 6, 7, 8, 2 XY analog keys. If you take a look at the numbers, you have 1 and 2 on the right, 3 and 4, and when you program these analog joysticks, that's where the numbers you're going to be manipulating in your programming code. Your power switch, 6 AAA batteries get installed under here. You have to remove a small Phillips head screwdriver, and it's also a 3-axis accelerometer built in with this joystick. You have 4 buttons on the front side, and this is your programming interface. We'll talk about it later. And where you plug in your USB key, so the other key will be right underneath here in this portion. For a view of the status buttons, the first one on top is your joystick. It will followed by the robot battery status. How's your robot doing? This is your Cortex responding to your joystick. and the communication link between the two, if they're being communicated or not. And finally, your game status. A green battery, it's good charge. A yellow battery means it's dying, and when you see any red buttons, that means it's dead. On the communication side, green VexNet COM established, yellow is searching. Lights on the controller and the joystick are the same. They should match the Cortex and the joystick. Pairing instructions. Start by connecting the charged 7.2 volt battery to the Cortex and inserting the key. Add the batteries to the joystick by removing the screw cover and install the batteries. Remove the screw in the middle and insert the batteries. After that, install your VexNet key, as seen here. Add the VexNet keys to the Cortex and joystick controller and power them both. Make sure you turn on the power button on both the joystick and the Cortex. A valid link is as shown. A VexNet light will be blinking a fast screen on both units. The robot light will wink green, be mostly on both units, and when using fully charged batteries. Very important that your batteries are fully charged. It will take about 10 to 15 seconds for a link line to be established. The joystick's light will be solid green. So the joystick will turn solid green, the very top one, when fully charged batteries. If it fails, turn off both the Cortex and the joystick and try again. Pairing instructions. Default code is automatically set once everything is paired appropriately. In order to test, you can add either the motors directly, or I would advise the motor controllers and then the motors attached to them. But add the motors and test. Plug the VexNet motors plugged into the motor port 2 and motor port 5. With default code, pushing joysticks channels 3, so this will be up, and this one up, to turn clockwise. Pushing joysticks channel up 2 will cause the motor 5 to turn counterclockwise. And this is the default code. Later on, we'll show you how to change the code. Programming your robot. We'll be programming the robot with RobotC. RobotC is a C-based programming language used in education, robotics, and for competitions. Using RobotC, you will be able to instruct your robot to carry out tasks autonomously as well as respond to the control inputs. Don't worry about the autonomous response. We will not be using this in this particular competition, in this level. On this particular section, we will meet again December 16th for a question and reflection on this course. Students will question, reflect, and collect resources to design a prototype solution for the problem. Thank you.
Hello, everyone, and welcome to the 3D Printing Saturday workshop for November 15th. My name is Orlando Benitez, and I'm going to be your Saturday workshop trainer for today's 3D printing session. So, for those of you who have not met me yet, my name is Orlando Benitez. I am the graphic and web designer at CSTEM, and I've actually built a 3D printer as well as printed something from that 3D printer before. I went ahead and installed the 3D printer myself and printed the design myself. Uh, so let's go ahead and get started here. So just so you guys know, we are in cycle 2, November 15, 2014. This is where we plan and conduct research for your separate challenges, your separate challenges. Um, so that's exactly what we're going to be doing today. We're going to be planning and conducting research for the 3D printing portion of the challenge. Now, I say 3D printed portion of the challenge, but in reality, there isn't a 3D printing challenge. There is 3D printing associated with the mobile tech challenge. So 3D printing is, within the mobile tech challenge. Um, and our job today is to figure out, or my job today is to make you familiar and get you ready and prepared for our, um, the mobile tech challenge. Um, the 3D printing within the mobile tech challenge. Sorry. So, uh, what is 3D printing? So, Google defines 3D printing as the process for making a physical object from a three-dimensional digital model, typically by laying down many successive thin layers of material. And I've gone over this before, but I'll go ahead and repeat it again. Essentially, what 3D printing means is making a virtual 3D object into a physical, tangible clone of itself. What does that mean? That means you take a 3D design that's on a computer from a 3D software and you print it using a 3D printer, and then you can hold it, you can play with it, you can use it, or do whatever it is that 3D printing objects function was meant to be. Hence, the picture on the right side here says, "What ideas would you bring to life?" Because really, that's what it is. You create something on a computer that's flat. It's sitting on a piece of software. It's flat. You can view it three-dimensionally, but it's still flat. It's in a computer. You can't touch it. You can't hold it. The 3D printer or 3D printing technology allows you to make that tangible, um, as you can see in the pictures there. Using material to print that. So where do we begin? Like any other technology, when you begin, it can be kind of confusing because it's a new thing. You don't know how to use it. I hear stories about when people first started using computers, they didn't know how to use them. But here we are nowadays, and you can see a computer pretty much anywhere you go. I mean, a cell phone nowadays is considered a mini computer. Um, so my job is to make sure that you can ease into the world of 3D printing technology very smoothly. Um, and I'm here to help. It's just don't panic. 3D printing is a very exciting technology, but it's also a very complicated one to understand at first. Um, so let's go ahead and get started. Now, for the Mobile Tech Challenge, you're gonna want to create. You're gonna want to, or the competition requires you to use 3D printing, 3D printing technology to create your mobile tech masterpieces. So, what does that mean for you guys? Well, the way I see it is, if you're gonna create a 3D printed masterpiece, for something that's mobile tech, you're gonna want it to be, technology that you can wear. And what that means to me is you got to be able to wear something that looks good, because let's face it, you can walk around with, the most high-end technology in the world, but if it doesn't look nice, nobody is going to buy it, and nobody is going to, wear it. And then that means that technology never gets used because simply because it didn't look cool. And that's something that a lot of the tech giants know nowadays. They take that into consideration. When you go out and buy a cell phone, do you want a cell phone that looks huge and bulky and it has antennas sticking out of the top, like 10 feet tall, 10 feet tall, maybe I'm a little exaggerating here, but, you get the idea. You want a phone that's sleek, that's thin, that's lightweight, something that you can hold and, talk to your personality and people can see and say, wow, that guy has that phone. It looks pretty cool. Um, so it's the same idea with mobile tech. You kind of want to create a masterpiece or a mobile tech piece that speaks to people's personalities and it speaks to fashion. Now, in order to do that though, you need a plan. You want to be able to know what your product does, and you want to be able to know what your product looks like. Um, so this is where blueprints come in. You have to do some pre-planning. It's important to have a plan before doing anything with anything. Um, you know when people go out and make shoes, or when people go out and make cell phones, or wearable watch, the iWatch, for example. you know People had to plan that. So make sure you sketch out a blueprint of what it is you need to print in order to make your 3D printed. I mean, in order to make your mobile tech pieces look nice. So just know what angle this certain piece has to go in, so that you can put these LED lights on, or what do you need to print so that you can hold this certain specific piece of technology, that kind of thing. You got to make sure you pre-plan these things, so that when it comes down to printing the actual thing, you don't have issues with, oh well, this doesn't fit here, it's not the right size, or it just doesn't look nice. And so pre-planning would help eliminate confusion with design and functionality. uh, Design is nice, but you also have to make sure that it's functional. Functionality is key. 3D printing allows for a lot of creative design, because it's additive technology. When you print something, you can design it on a computer the way to look however you want. Obviously there's some size requirements for this competition, because we wouldn't want you to build an entire house. Not that that's even possible, because no one's ever built a built a 3D printed house before. Not yet, anyways. Um, but there's no limitations to creativity. But you also have to what that means is that people will go off the wall with designs, and that's fine. We encourage creativity, but functionality is key. You have to make sure that your design works. Like I said, you don't want to end up with a piece that just doesn't fit with the technology that you have. um, and the way I think of it is, think of the Ford Pinto incident. um, back in the days, way before my time, that's for sure. There was a car called the Ford Pinto. This one here in the green on the bottom right. Well, actually, all of these. And it's a nice looking car even by today's standards. But the problem is that it was pretty much it was just bad design. It was a death trap, to say the least. There were stories where if you hit the car from the rear at speeds as low as 30 miles per hour, your car would pretty much explode into a um, fiery explosion, as you can see in the left image. And that's because Ford rushed production on these vehicles, and they were too worried about the design, that they didn't really think much about the functionality. There was just all kinds of problems with this car. And so that hence the meme in the middle. Hit a speed bump, fire everywhere. um, so make sure that it is functional before you start making it look nice. Here's an example of a really cool design, actually, a 3D printed design. Um, This doesn't have to do with mobile tech, but it's just an idea. It just shows you. It's just a little gives you an idea of how a cool design can be functional. Um, this is a water sprinkler, and actually I think I linked to your YouTube video. You can see here um, on the left side the two pieces that the designer used to make this um, sprinkler. So let's go ahead and watch the video and see, just give you an example of how it can be functional and look cool. So there you go. It can look cool and it can be functional. So software. In order to build our 3D printed models, we have to use a software, correct? And in our instance, we're going to be using Google SketchUp. Uh, and don't worry, this program is 100% free and anybody can download it. You just have to make sure to download Google SketchUp Make. There is a Google SketchUp Pro version, but we won't be needing that. That's for more professionals, architects and that kind of stuff. We're not building buildings right now. We're just building um, mobile tech masterpieces. So you can click on the link here below to take you to the download link, or if that link doesn't work, you can always just Google it, and it'll come up immediately because it is a Google product. So let's go ahead and just show you how I would go about it. You go to Google, you look up Google SketchUp. There it is. And the first link you'll see is Google SketchUp Pro, but you don't want to click on that. So let's go ahead and look up Google SketchUp Make. Let's go ahead and click on the second. Oh, no, that's Google SketchUp Pro. Let's go ahead and click on this link here. See where that takes us. Oh, nope. So let's do this. Let's look up Google SketchUp. We'll click here on Google SketchUp Pro, and it'll probably take us to Google SketchUp Pro site, but we don't want the Google SketchUp Pro site. So when you get to this site here, go up to products and click on Google SketchUp Make, and then you hit download. And once you get to this page, it'll ask you to choose a product, and choose explain what you're using it for, and just use educational use. Fill out your email address here. Fill out the information here, and what operating system, Windows or Mac, and then choose a product. This is where you have to make sure you click on Google SketchUp Make. Once you click on that, you click download, and it'll begin to download. It'll begin to download the wizard that you can install so you can install it on your computer. So once you download that, go ahead and start messing with it, get familiar with it, because we will go more in depth into how to use the tools within Google SketchUp for our next Saturday workshops. But for now, just go ahead and have it available so that when we get to the next Saturday workshop, you can be somewhat familiar with where some of the tools are, and what they do, or just how they work. So again, I'd like to thank you for joining me for this Saturday workshop. Again, we encourage everybody to upload their images and show their work through SystemBreak. We'd like to see what you guys are working on, where you're at with the process, and if you have any questions, you can always ask, or you can ask me on Orlando Benitez, my SystemBreak page, and I will be more than happy to answer them. In fact, we are, right after this session, I'll be, available for the next 15 minutes or so to talk about to answer any questions regarding the 3D printing process. But before I go, I'm going to leave you with these resources here. Here are two websites where you can go and check out, 3D printing models that people have created for numerous things. In fact, this is the one on the right side is the site where I found the 3D printed sprinkler that I showed you earlier today in the video. So just go ahead and start generating inspiration from these two websites. Start looking around and just get an idea of some really cool concepts. So again, if you have any questions, feel free to contact me. My name is Orlando Benitez. You can reach me at my email address, media@cstem.org, or simply reach out to me at via CSTEM Break at Orlando Benitez, my my page, CSTEM Break page. Um, Again, I'll be available for the next 15 minutes to answer any questions regarding 3D printing. And thanks again for joining me, and I look forward to seeing you guys for the next Saturday workshop on let's see, on December, I believe. So thank you very much, and I'll see you then. Hello everyone, my name is Orlando Benitez and today I'm going to be your Saturday workshop trainer for BristolBots, Ingenuity at its funnest. So, who am I? Well, like I said, my name is Orlando Benitez and I am actually the graphic web designer here at CSTEM. So I'm actually pretty tech savvy and I, like to tinker with things. I am what, uh, you like to call an artist and an engineer, so working at system it kind of fits perfectly. And so the nice thing about Bristol bots is that you don't have to be extremely tech savvy to use them. You just got to be able to like to do arts and crafts or mess with something, um you know just be creative. um So let's get started in identifying why you're here. So you're watching this Saturday workshop because the pre-K through first graders are going to be using the Bristol bots for the robotics challenge portion of the system challenge. So in this training, we're going to go over what is a Bristol bot, what is a Bristol bot, sorry, and just how simple it is to use it and build it. So what is a Bristol bot? Um, Google defines a Bristol bot, or another word for them would be brushbot, as an extremely simple form of a walking robot. So it's essentially one of the simplest forms of mobile robots there can be, simply because its primary function is to move, and that's it. There is no specifications on what direction it needs to move. There's no specifications on how fast or how slow, when to stop. It just moves. Um, and that's why, it's identified as just a simple robot. So what's the history of Bristol bots? How long have they been around? Uh, who came up with Bristol bots? Because, somebody had to come up with it. Somebody had to be tinkering with things and figured out that, hey, you can build a Bristol bot out of just toothbrushes and motors. Um, so that guy actually is Neil A. Downey, and he's pretty much the pioneer of Bristol bots. The concept first started in, or the concept first was seen in his book, um, Vacuum Bazookas, Electric Rainbow Jelly, and 27 other Saturday science projects. Now, uh, this book actually shows you how to make simple science projects, using tools that you have at home, or simple tools um, that anybody can obtain. And the design for the Bristol bot was in this book. So if you wanted to actually go and purchase this book, you can find the Bristol bot design along with a lot of other really fun designs um, in the book. And I actually went ahead and linked it here in a PowerPoint for you guys to be able to access it if you're interested. It'll take you to Amazon so you can buy it. But like anything else in the world, people argue about the origin of Bristol bots. A lot of people have said Bristol bots, they've been around forever. People have used, they've used brushed, you know, vibrating, vibrating machinery, or vibrating technology to be able to move things. So this isn't new, but he was the first one to actually implement it into like a little science project using toothbrushes. So what are they made of? Now, like I said before, these are extremely simple robots, but extremely fun as well. And the reason why they're extremely simple is because all you need to make them is a toothbrush head, um, a rumble motor, as seen, on the third picture there, and a battery. Typically, people use a lithium-ion battery or a small uh, battery, but I have seen Bristol bots that use AAA batteries, AA batteries, that kind of thing. Uh, you're also going to need wires because you are trying to transfer the energy um, from the battery to the motor. and tape or glue, just to be able to hold it together. But that's it. It doesn't require you to code anything. It doesn't require you to be able to solder anything, or that kind of thing. So it's these are materials that anybody can buy on Amazon, and they're fairly inexpensive. I mean, you can buy a toothbrush at your local CVS or your local Walgreens. Um, you can buy the batteries there as well. The only thing you would probably need to order online would be the motors, the rumble motors, and the wires. But you could probably get those at a hardware store. So, how do you make a Bristol bot? Well, here's an image that shows kind of how a Bristol bot looks. But, oops, I went ahead and added a link here. It's actually not letting me access it. No worries, I'll just copy and paste that. So I've already, I went ahead and added a link to the PowerPoint where you can click on it, and it'll take you to an instructables.com web page that somebody has created that shows you how to create this specific Bristol bot here. Now, keep in mind, they use a two-sided tape here to stick the battery as well as the roller motors to the top of the brush head, but it's essentially the same tools that I have specified in the PowerPoint. It's just the adhesive holding it together with the battery, the rumble motor, and the Bristol bot, or the brush head. Sorry. You can go ahead and take a look at that if you want to do that at home when you have the time or access to the materials. But why does it all matter? Why are these Bristol bots important? We can build it at home, but it's just a toy, right? Well, it's interesting really because Bristol bots are a very simple machine, like I stated before, but it doesn't have to be. You can add motion to a Bristol bot, but the next step would be figuring out how to control that movement. How do you make a robot move, a specific direction? How do you make it move left, right, up, down, and at what speed? And it's interesting because there is these other version of Bristol bots called kilobots. And these kilobots were created by, I believe it was Harvard students. And the idea was to create a multitude of Bristol bots, as you see above. These don't have two brushes, but they're sitting on three little spaghetti-like little twig legs. That allows them to move around, kind of the way a brush does. So think of like a brush head with just three brushes. I know it's kind of difficult, but same concept. But like I said, the students at Harvard created these kilobots, and the idea was, well, what if we can control a multitude of robots to move in coordination with each other? Can we get tons of robots to form specific shapes, and by being able to move in comparison to each other. The way I think of it is think of a marching band, like a college marching band. When you go to events and they start moving around, there's a whole bunch of snare, and like instrument players and marchers, but they're moving in conjunction with each other to create specific shapes or effects on the field. Well, it's the same idea, except they're small little Bristol bots or kilobots. And I encourage you to go ahead and read this article linked here that shows just the power of simple machines. This is extremely interesting. Extremely interesting because if you see here, you can see the little robots moving around each other to create this shape, and it's crazy, because if you think of what the possibilities of this, if you can think of all the possibilities of this technology, already I can think of being able to construct or reconstruct part of a machine that has broken using robots that kind of just form a shape. Now, obviously, we're a couple years away from that kind of technology, but this is kind of like a start towards that. If we can get a whole bunch of like nanobots to reform part of like let's say a crane that has broken um, in a couple minutes and hold together using some kind of magnets the way these guys these little kiddo bots do, um, then we can move forward with like how you what you see in sci-fi films where you throw little nanobots and they start forming different shapes and tools and that kind of thing, and it's really crazy how um, technology can do these kind of things. Now, keep in mind, these little kilobots, each one is smaller than a quarter. So that kind of gives you an idea of how, small these things are. And that's about the size of our, the Bristol bots. The size about, that's about the size of how Bristol bots can get. Um, you know, I guess, depending on the size of your brush head, it'll be a little bigger, but, it's about the same size. But that just goes to show, that's a great example of, just being an artist and an engineer. And here's some other examples of people who use BristolBot technology to create other gadgets. These students here actually created a BristolBot sort of, I want to say hoverboard, but it's obviously not hovering, but it gives you that same effect. If you have something that's vibrating extremely quick on little, brushes, it'll be able to kind of glide through a smooth surface the way these students are. So, bristle bottles don't have to be small. They're small just because, we're using brush heads and small batteries, but, they can, the technology can be something as cool as, you know, uh, I guess hoverboard, if you want to believe that. Um, so now moving on to the Bristol bots you'll be using. You don't have to get the Bristol bots. Um, you don't have to get the Bristol bot parts mentioned before, and that's because we've already supplied you with pre-made Bristol bots. If we go to the front of the PowerPoint, in your toolkit, you should have gotten Bristol bots that resemble these Bristol bots here. These are actually the Bristol bots that you will be using for the competition. Uh, as you can see, they have the battery, the wires, as well as some little um, extras like googly eyes and tentacles there to kind of help stabilize it and just make it look fun. And so that brings me to my next point. Make them your own. You want to be able to stand out when you're creating these Bristol bots. These are supposed to be fun, creative robots. So make them your own. Go ahead and add your own taste to it. The set already comes with googly eyes and colorful rubber bands so that you can hold it together. But you're not limited to what you can do with these Bristol bots. Here are some examples that I found online of people who have created Bristol bots and made them their own. You can see, some of them look like small bugs at the top left. There's one that looks like a dog in the middle. There's obviously the one there with googly eyes, and even one that looks like the character from Pixar's Disney Pixar's movie. Uh, Let me see if I can remember Turbo, the little snail. They 3D printed the little snail there, and on the bottom right here, and stuck a brush head to it with a mortar. And here's just some more examples of Bristol bots being used creatively. You can see the butterfly ones. They probably flap their wings, because the mortar makes the entire thing vibrate, and they probably, they actually look like they're moving. So that's pretty neat. So make the Bristol bots your own. Add your own taste to it. Obviously, you want to make sure that your Bristol bots are still functional and that you can get them through to the robotics field. That way, make sure you just don't put yourself at a disadvantage with your design. Make sure that it's not it doesn't have like as cool as these butterflies look. Make sure it just doesn't tip over your robot when you put them on the field, because otherwise you'll be at a disadvantage. And you won't be able to get as many Bristol bots through the finish line as you want. So here's just some resources that you can go ahead and take a look at for Bristol bots. There's the Hexbugs toys that you can actually order, which are a more industrialized version of the Bristol bots. They look like like something that came out of a Toys R Us or something because they, like I said, they're industrial toys. These are already molded and everything, and they look nice. But it's the same concept. They turn on, they have a switch, and they vibrate and move around. Um, and just go ahead and I went ahead and included the Bristol bot how to build here, another one here. So if you want to build another type of Bristol bot, you have the links here. Um, so make sure you stay in touch with each other here on C-STEM Break. We want to hear from you guys. We want to see what you guys are working on. So especially with these Bristol bots, I'm actually pretty interested to see what kind of creative Bristol bots you guys create. Because they're small little robots, but they're fun. So go ahead and send us your pictures. Show us show us how creative your pre-K through first students can get. Um, I'm actually pretty interested to see them. Not, like I said before, just you can do that all through C-STEM Break. Upload your images, and they pop up in the front page, and we can all see them. So go ahead and just show it off. If you got a really good idea, put it out there. Um, because like I said, we're pretty interested to see what you guys are working on. So this is we are currently in cycle 2. Uh, where students are planning and let's see, planning and strategizing um, what they're gonna do with the robotics or Bristol bots. And we I look forward to seeing you guys on December 6th for cycle 3 for our next Saturday workshop. Um, if you have any questions, feel free to reach out to me at media@cstem.org. And um, let's see. Yeah, feel free to reach out to me at media@cstem.org, or you can just contact me on CSTEM Break on my CSTEM Break account, Orlando Benitez. Um, if you guys have any further questions now, I'll be open for the next about 15 minutes to chat about the to chat below in the chat box below and try to answer as much questions as possible, or try to answer all of your questions as as good as I can. So like I said, I look forward to seeing you December 6th, and thank you for attending the Saturday workshop.
I hope everyone's having an exciting Saturday morning. I like to begin this sculpture workshop in class with 3 keys. Organize, envision, and improvise. In organizing, you can plan out your activities by simply creating order. There's many ways of creating order. Some of the methods I use are to put things in order by color, shape, size, and the material they're made from. Sometimes by analyzing size and colors, you can join things together and understand how they work or how they seem to operate together. And sometimes how things seem to fit together can lead to other ways of thinking about what your materials are. I prepared some slides here that I hope can kind of inspire and give you guys some ideas of what you might want to do and where your interests are in working with found objects and found materials, recycled materials. My next key is envision. Think of the future. Think of some of the things that you can see around you that may have a different use in the future. Reappropriating an object. A bottle is more than a bottle. It can hold sand, it can hold water, it can hold air, it can hold pressure. It can float, it can be made heavy, it can be joined, it could be a pump, it could be, there's as many use for a bottle or a cap, a string, a wire, a sheet of paper, or a piece of paper. You can use different colored paper. Sheets of paper is the same way you can use paint. Through the organizing process, you can think about how you might want to envision putting a group of blues together or a group of yellows together to create the effect of something being green, as opposed to simply resorting to paint, which I know you guys can't use. Picture something that challenges the possibilities of what's before you, the materials you've decided to work from. Keep them in mind through your course of designing. Draw as much as you can. Draw out the shapes, draw out the ideas that the colors bring to mind. Keep notes on each step of your process because it may become useful in later challenging moments throughout this sculpture building. And also it can provide inspiration for your colleagues, for your fellow students who are working on the project with you. The more content and process you employ in your process, in your building, and in your design, the more information you have in your writing aspect of describing what you've done and remembering what you've done and what you've learned. I like Theo's work because he seems to have found a use for cooperation with the wind, water, and the earth beneath his object's feet. His mechanical process has been adapted to work with what he can find and what already exists. He's fabricating based on necessity, adapting. I think all of this is a part of the creative process, which I like to think of as envisioning something, keeping it in your head and on the page until you've developed something that you can bring into reality based on what's around you. Keep designing, keep drawing, keep thinking of something you haven't seen before in the way things connect, or something you'd like to see happen that you've never seen happen in the way that things can connect, plastic and paper, or wire and paper. There's many processes that you can use to build your desired design. The next part and the final part of my 3 keys is improvise. Look for ways to improvise. Look at what your colleagues are doing. Look at what your fellow students are doing. Think about what your teacher is seeing, and think about what you're seeing and how you're examining the objects you've collected that you're going to build from, the integrity of the objects, how they feel, what the weight of them are, what can be done with them. Play with everything as much as you can. In the process of improvisation, you are simply adapting to what you've learned about your materials and kind of understanding through play how you can make something that is functional. Everything is possible. Everything is possible. Everything is possible through testing your materials. Continue to test your materials. Figure out how your materials work. Figure out how they are going to get you to your ultimate goal. Invent what you don't see there. Think about what structure is and how to build upon it. Paper can be folded to make beams. Bottles can be cut and re-rolled to make struts or pumps. There's many, many uses for everything you have around you. Don't let anything go to waste. No ideas, no scraps. Think about everything as being functional. Somehow art is simply finding a way to make things function for the imagination. Look for the function in every step of the way. Be creative. Push your materials. Build layers. Put everything in that you can. I wish you all the best of luck with your challenge. And if there's anything you need to know from me, feel free to ask any questions. Send me messages in the text box here. I'm looking forward to our next session. Good luck today.
Energy infrastructure, wind, oil, and natural gas. Welcome to the November 15th Mural Teacher Training. I am Sarah Trotty and look forward to this presentation with you. Some of you were not with me on our last visit, so just to review, I've recently retired from Texas Southern University after 31 years as an art professor there, also working as department chair on and off. I have developed walking tours of the many murals that we have on our campus and have worked to give tours to visiting schools. You'll find that there are over 128 murals on the campus, many of them full of symbolism and stories. And these are great motivations. So you can visit the TSU murals either in person or online. Let's talk about this challenge, the mural activity. What are the expected outcomes? Teachers and students will engage with professionals that connect STEM industries with classroom learning. They will learn about innovative and relevant content, tools, and resources that inspire leadership, creativity, entrepreneurship, critical and solutions-driven thinking, and advances STEM knowledge and skills to allow them to create innovative solutions to problems they have been given to solve. Let's talk about the framework, what's to be done at each level. The murals made by the elementary school age students, and those are K through 1 and 2 through 5 in most cases, and sometimes 2 through 6 for the elementary. The theme for this group is energy infrastructure, wind, oil, and natural gas. The students will conduct the research that will provide the reference materials that inspire the visual images that they create to convey their inspiration or message. Their research presentations must go further than the actual production of the murals. They will engage in written, oral, and technology presentations as well. There are resources such as online searches, interviews with professionals, and field trips that can be useful and helpful to enrich student engagement in the scientific investigation. There are also other levels that we can talk about before we move on. I want to mention as well that there will be a similar theme for middle school and for the high school. Now, just a little bit of background about murals. Historically, murals were large drawings or paintings on cave or building walls, such as the caves in Lascaux, France, Altamira, Spain, or South Central Africa, or the early architectural structures often found in Europe and other parts of the world known as frescoes. Modern murals today have been painted on canvases glued to walls, according to Wikipedia, or according to current practices. Canvases can be stretched on or hung on walls that are stretched on boards. Techniques and materials vary greatly from the traditional water-based paints to wet plaster to oil paints or acrylic paints or pastels. Wikipedia also provides valuable research and it's a good place to start before beginning to work on the murals. You will find, if you go to that site, murals in Belfast, Cuba, Los Angeles, Mexico, New York, Nicaragua, among many other places. So to investigate these murals and some of the others, let's just take a little look at some examples of what you find. When you go to sites like Wikipedia, you can certainly click on the history, which carries you back to look at some of the techniques and historical techniques of the material. You can click on other topics such as the techniques and see how these murals are done. So there are also murals that deal with issues and politics and more, sometimes just for design. So that's one way of getting the background, beginning the background. But again, there are many other sources that you can follow. Many cities in the United States have murals. The Works Progress Association sponsored most of these murals during the early recession. Let's just take a look at some early works, early murals of the Works Progress Administration. These are some of the murals that show and works by people in the community putting them back to work. So you can see in this particular mural, they are showing workers, whether they were working in with cotton or working in stone. You can see murals that tell a little bit about the Texas landscape and culture. So there are all kinds of mural examples that you can see by just visiting one of these sites. Now let's talk about how we would approach this mural challenge this year. One of the first things you need to do is to begin to set up the teams who are going to work together to create successful murals. The teams should be identified according to the activities that they will undertake. There should be a mural construction team because you'll find out as we move on further that there's quite a process of putting this whole piece together to create the canvas that will hold the murals. And so if there's students who just like making things and working with their hands, this might be a good team for them. Then you have the mural research team. This team, as I've shown in a few of those examples earlier, would begin to research the history of murals. Uh, the work of John Biggers, and we'll speak about him a little bit more a little later on. They'll also collect images of this year's theme, water, oil, and gas infrastructures. Then there's the theme research group. This team will actually do the collection of data and information to put together a body of knowledge that will be useful in the construction of the mural and then will be useful later on in the written and oral presentation. Then you have your artist design team. This is the team that would study those images that were generated related to the theme and design several compositions, maybe at least 4, that would be useful in conveying the concept of the mural masterpiece this year. They would be the ones who also sketch and apply the color to complete the mural. Then you have your writing and presentation team. These are young people who enjoy writing, enjoy speaking to a group, and can pull together their understanding of this research and knowledge to make a strong presentation. Now, let's talk about the construction of the mural and move ahead to another slide. The dimensions of the mural. The elementary school will have 3 canvas boards, and these have been supplied. So there's no construction necessary if they're grades K through 1. Their art final pieces will be displayed on tables. The other murals will be hung on the walls and will require more construction. Elementary schools, grades 2 to 5, and sometimes in some districts 2 to 6, have received 2 38-inch by 36-inch pieces of muslin cloth. These cloths will be used to construct the canvases, which will be 35 inches long by 70 inches wide when sewn together and hemmed on the 2 sides and bottom, and with the 2-inch hem on the top to provide a rod hanger sleeve. The middle school canvas will be the same size, again 38 inches by 36 inches, 2 pieces that will be put together to construct the 35-inch long by 70-inch wide canvas. High schoolers will have 4 or will receive 4 pieces of muslin cloth. They will start out the same size, 38 by 36 inches, but when sewn together and hemmed, will be 70 inches long by 72 inches wide, with a 2-inch rod sleeve on the top. Now, constructing these mural canvases. To start, and I'll have some slides that will show you examples in just a moment, students should neatly press the 2 pieces of muslin cloth first. Then these pieces should be laid out on a floor or table side by side in a vertical arrangement so that the two 36-inch sizes are adjacent and form the width, and the 38-inch size is the length. Then fold under 1/2 inch strips. Will be pressed, and I'll show you a slide and how that's done. These should be pressed down so that they would stay in place. Then using a sewing machine, and of course elementary students will need help in creating this, so parents and teachers are welcome at this point. Using a sewing machine, it'll sew the two vertical cloths together at the seam first, then hem these two vertical sides that were pressed already a 1/2 inch, and then next press down the bottom hem and sew the bottom of the two adjoined cloths. And this will give a 1/2 inch border on the two sides and the bottom. And then to make the top hanger fold, first press under 1/2 inch fold. Now this can be sewn or stitched down to make it stronger. And then fold over from the top again 2 inches. And once that's been folded and pressed, then a final seam will lock these together. This photograph shows you an example of the two pieces of cloth that have been sewn together to create a much larger piece. The final double cloth panel, as mentioned, will be 35 inches by 70 inches. And this cloth now is ready to be coated to create the actual canvas itself. Now, to coat this canvas, you're going to use just simple latex wall paint, white. That has not been provided. It's difficult to mail a can of paint to you. However, almost everyone can find in a closet somewhere a can of unused or remaining white paint, latex again, so that it dries quickly. Put plenty of newspaper on the floor, then cover it with some plastic. It can be cleaner's bags or any kind of drop cloth. And then through the top, that 2-inch area for holding the rod, pull through some plastic just to keep it from soaking through. Once this is ready, begin to apply the white latex paint in dry brush strokes, which means not too much paint on the brush. Clean the edges of the brush well after dipping it, and begin to carefully overlap strokes of paint. Allow the first coat to dry, and then put on a second, maybe even a third coat with a dry brush before adding the final smooth coat of paint on the canvas. And this time, a little more paint. Don't soak it, but a little more paint can be added until you have a nice smooth surface like a wall. Mural canvas construction from the high school is just a little bit different. Instead of 2 pieces of muslin cloth, the high schoolers will receive 4 pieces of muslin cloth. Now, you may have received 2 in your packet, but 2 more will be arriving fairly shortly. Lay 2 of the cloths side by side, just as the elementary and middle schoolers did, to create a vertical arrangement so that the 36-inch sides are adjacent to each other and form them, and the 38-inch is the width. Then fold under, as said before, 1/2 strips on each side of these 2 pieces of cloth. Press them again so that the 1/2 inch seams stay in place. Then hem them using the sewing machine. Once that is done, do the same thing again with the 2 remaining pieces of muslin cloth. Now these 2 large pieces will be seamed together in the middle so that you have one larger structure. The seams again will have the length, this time the 72 inches will be reduced once the 1/2 inch is sewn together to 71 inch. And the 2 sides together, the 38 inches, of course, were already seamed together to create a 77-inch width. Now, Prepare to make the top hanger or rod hanger as in the previous slides. Fold under 1/2 inch, press it, sew it down, then fold that over again to create a 2-inch sleeve. Press that and sew this down. This creates a nice strong surface. The slide that you see now is the 2-inch, and you can see the 1/2 inch folded under already. And this is the way the top sleeve will look for all three of the groups, the levels that are creating a canvas mural. You can see in the following slide that this is pressed into place so that it's a nice, good straight edge and will hold. And then finally, it is seamed right on top of the lower folded edge that was 1/2 inch, so that you leave that 2-inch space in the center, which now is just a little bit smaller than 2 inches, but plenty big enough to hold a rod. Now, for high schoolers, this final 4-panel cloth will be 70 inches in length because of reducing it by the 2.5 inches at the top and 1/2 at the bottom from the original 36 inches that were sewn together. And it'll be 72 inches in width. And it also now is ready for the 2 or 3 coats of white latex paint that's applied in a dry brush manner, and then later the smoother application of a little more paint to give a good surface. This should dry completely before it's ready to use. Now you can see how long this process takes, and that's why it's important that there's a team ready to go to assemble the canvas. Then as the other teams begin to work, you know you have the research team already beginning to do the research, and we'll talk a little bit more about the research a little bit later on. And you have the design team. The design team can begin to look at not only the images that are coming up, but the challenge will include images of the 3 characters that you see listed here. Let's just think of them as our foretellers of the story, those who are guiding us through the mural. So we have the characters Sprout, Squirt, and Slippery. This is the way they look, and this particular slide that will remain in the instructions will show you how to create these characters. Now, the way the teams engage these characters in the final mural will help convey their individual stories about about the wind, oil, and gas infrastructure. Now, let's talk about some more of the research. For inspiration, we are using the work Spring Renewal by Dr. John Biggers. Dr. Biggers' work has been used throughout this experience of CSTEM to help students understand the importance of communicating through a large visual painting. That's what we call the mural. And as you look at this particular work, you can see that he's used both geometry and simplified realism to convey the message. So we want to talk about how he's used his work. So some students should be researching Dr. John Biggers and this particular mural, as well as some of his other works, to see that. And also we want to mention that the turtle is one of the animal images, as you can see here, that shows up in his work quite often. So research how he's used the turtles, because that's another symbol that can be a very strong part of your mural. And also realize that the murals that you create should have some geometric pattern in the work, just as he's used that in his. His use of geometry was inspired by his understanding of mathematics and geometry as a universal aspect of our world. So we talk about sacred geometry, and we'll just take a look first here at how geometric shapes can be created from the basic geometric shapes are created using simple shapes such as rectangles, ovals, straight lines to create angles and they can be extremely interesting in design. And this is the kind of thing that Biggers used in his work. You can use this particular slide as well and look at some of the other research that's been created. All right, I just want you to get a little idea how that geometry was built up to create this image. Let's look at some other sites of sacred geometry just to get a little bit of possible designs and see how they've been used as a part of stained glass, how they've been used in science to show anatomy, how they can be found in nature. And every culture pretty much has used some kind of geometry in its design and replication of nature. Sacred geometry is based on this pattern of mathematical repetition in nature. And you can see this golden mean is one that's inspired men in art throughout the centuries. I'll take you to one more link, but I want you to go on and do some research on your own with this. And this one will talk with you more about sacred geometry, the golden section, how we see geometry in, in nature. And that's important because as we talk about wind, oil, and gas infrastructure, we're always thinking about nature and its impact on nature. Just so you can get some examples of how geometry has affected design, just take a look at all these many patterns and architectural structures and designs that have been created throughout the century, and even as you find them in nature today, as this peacock that's there, even looking at the water pattern here, which is almost kind of a replica of the golden mean, but it's a natural sense of that. Water drops creating circular patterns. So geometry is all around us, and we can think of this and look at it as both design and as science. When you're planning your murals, you're also going to decide on colors to use. So just want you to start thinking about how color works. This is another part of the research, and the art team certainly should be engaged in the research of color because they're going to use these colors to help create the murals. There's an example of the color wheel here and how colors work. We want to think of not only using colors straight out of the tube, which are called pure colors, but colors that are toned down or created tones by mixing complementary colors, those colors opposite on the color wheel, to create softer colors, or using shades such as adding black or brown to the color, or adding white to create a tinted color. As we go to this link, you can learn so much about color just by doing a little research. I advise you to go to the various sites that you can find, as well as some of the great textbooks on color, and use some information on color. Also want to talk with those teams that are doing the research on our theme, energy infrastructure, wind, oil, and natural gas. Listen to the public media stations such as radio and public TV stations. Almost all of them have an energy expert or environmental expert, someone who's looking into the changes in our consumption of these natural sources and use for energy. So you can find out much about it. Every city has a public station, so we want to just suggest that you go to those stations and look up and find out what they offer. Now, in thinking about this theme, oil and gas, there's so many areas that you can look at and about moving the oil and the gas. The petroleum industry utilizes three major methods that are listed here on this particular slide. So look at that a little bit more in depth. Midstream involves the transportation and movement of this oil by pipeline, rail, barge, oil tanker, or truck. So as you're looking this up, you'll find images that you can use in the mural itself. And then there are ways of storing these energy sources. So you want to look those up as well. I did put a link here and we'll look at it quickly. And it's taking a little longer to load. It's a larger link. This particular one will provide you with lots of resources and information about the oil energy process. Won't go into a lot of detail, but you can just begin to find charts, graphs, lots of information about how energy works and how it works across this country as its map shows. Now, wind power would be different. And of course, most of us have become familiar now with wind as a means of generating the power so that we can bring electricity to our homes and businesses. There are many pros and cons about all of these energy sources, so certainly look those up. And then look at the importance of how they work to improve our lives. There's a source here about wind power, and you begin to see how this works. So I provided that link for you. Not going to go through all of these. We're going to move on through here. And there's a source of images that are likewise available. So many places across the United States, especially in the West, have these wind power farms. And just begin to look at some of the research. And you can include some of this imagery in the murals that you're creating for understanding. Now, we are in cycle 2 today, November 15th, where you plan and conduct the research. We're mainly talking about today doing the research, all that preparatory work that's necessary to come up with a good project. So we want you to keep that in mind. We're not talking about the final project at this point, but coming up with strategies for using this information, using the software and programs and tools and resources that are there to help you understand what this energy is about. That pretty much prepares us to move forward. We want you to know that you can find this particular presentation on CSTEM Break, and there will be Saturday workshops available for you and opportunities to dialogue if you have questions. So by all means, please submit any questions that you have. And we are looking forward to the next opportunity to talk with you, and I'll be available in just a few minutes to talk with you more. Thank you.
Hello, 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 and good afternoon, and welcome to the November 15th training session for documentary filmmaking. I'm your instructor, Lori Mitchell. How are you guys doing today? I hope great. So let's get into it. This section, we're going to talk about planning and conducting research. So, students, you guys will conduct research and finalize proposed strategies using related software, programs, tools, and resources. And this year's theme should showcase the economic and overall benefits of updating the current United States infrastructure that transport energy produced by wind, oil, and natural gas. So that's where your documentary is gonna focus. So let's go into our planning stages, which is our pre-production stage when you're making a documentary film. Pre-production is all about what needs to be done before the shooting or editing begins. Just like building a house, take longer than the actual building of the house. It's the same with filmmaking. And in fact, it's a mistake to rush into shooting without thinking everything through. So you want to make sure you're organized. Any film, the organization, you can always tell if a film um, was planned properly just based off of the look of it and how it flows. So pre-production planning is very important in filmmaking. So I just wanted to introduce this to you guys. It's a diagram, that we use in the film world. It's called good, fast, and cheap. So a film can be good, fast, and cheap, but you can only pick 2 out of the 3. So if you do a fast and cheap film, it won't be good. If you do a cheap and good film, it won't be fast. And if you do a fast and good film, it won't be cheap. So you have to decide which of the 2 you would want to do to make sure that your film is a great product. So I just wanted to introduce that to you guys so you'll know that that's how we look at filmmaking when we're in the planning stages. We always want a good film, so it's either going to be good and fast or good and cheap. But the focus is have a good film, and that's what you guys are going to have, a good documentary film. Okay, so let's go to the pre-production checklist. So you want to write the script outline during pre-production, create an interview and shot list after you've done the script. And of course, because you're creating an interview and shot list, you have to find people to interview. Create a production schedule, create an equipment list, gather additional footage, and find someone to do your music. Today, we're going to discuss writing the script outline and creating an interview and shot list. So when you're writing the script outline, you may think to yourself, how can I write a script before I've shot anything? And that's a great question. It's true that the nature of documentaries is that it is unscripted, meaning nothing is on paper, you're just going with the flow of things. So what you can do is imagine what your documentary is going to look like and craft a pretend script or outline based on the information that you have so far about your topic. You'll be amazed how helpful this process can help you think of scenes and possibilities that may not have been thought of otherwise. So, how to start on the script? Research. That's the main thing. You want to research your topic. Once you've settled on your documentary idea, it's time to just get in there and start researching. Then you want to create a list. Based on your research, start creating a list of potential interviews, basic storylines, areas of potential conflict and emotion. Ask yourself, what's at the heart of this story and how do I show that visually? You want people to feel something when they're watching your film. Get a style. Decide on how you're going to how it's going to look, how it's going to feel, the style of documentary. Search the web for videos or watch TV for ideas. Netflix, if some of you guys parents are okay with you watching Netflix, Netflix is a great resource for documentaries. Or you could try, there's this website called Top Documentary Film, topdocumentaryfilm.com, and there's a documentary on everything, anything that you could think of. And so start watching documentary films that could possibly help you guys to see how a documentary flows. You want to include the following: the summary of the documentary, goal and purpose of a film. Outline your script so that you can make sure that it has all of the good short story components. In your outline, describe each section of your film. Now, I think you guys are doing a short film, so your outline does not need to be longer than 300 words. You know, you need to prioritize your scenes for your outline. Identify priority scenes. Develop character motivation. And your characters are just simply people that you're going to interview. So characters without motivation or personality aren't really great for a documentary. So interview people who are going to create emotion in you guys. So remember your documentary story. So when you're doing a documentary, you want the following. It should cover exposition, rising action, conflict, climax, falling action, and resolution. So under your exposition, you want to know what kind of information you're trying to get across. So that's your introduction. Your rising action, it should be, here is saying what event in the rising action will draw in the reader, but it should be what event in the rising action would draw in the viewers. What types of conflicts are present under conflicts, and in your climax, this is often considered the most exciting part of the film. And so in your falling action, it should be the different from the first part of your story, but you're coming down to your point, and the resolution is just simply ending your film. And I also placed on my C-STEM break a documentary that it will help you pinpoint I want you guys to go over and pinpoint what is the exposition, what's the rising action, conflicts, climax, falling action, and resolution. So it'll help you understand these terms a little better, and you can identify it. So when you do your own, you know exactly what needs to be done. Okay, so let's go to interviews. When you're doing an interview, or when you're creating the interviews, you want to make sure you create an interview interview questions that's going to answer who, what, where, when, why, or how. You want to make sure that your interviewee repeats back to you the answer. So, for example, if you're interviewing someone and you say, well, when was the first time that you knew you loved school? You want the interviewee to say, the first time I loved school was in the 3rd grade, or something to that effect. But they must say the question back to you so that when it's time to edit, your editor can easily go through that. When you have time, I've placed the YouTube video here, how to interview for a documentary, and it'll go over what I just stated. But you guys, please make sure you have all those questions answered when you're creating questions for your interviews. Your shot list. By creating a shot list, your entire production runs more effectively, because everything gets short based on the location. Everything gets shot based on the location and the setup. as opposed to the order scenes appearing in the script. A shot list is similar to a storyboard because it identifies what's being shot. It also can be easily distributed to cast and crew. It gets the director, cinematographer, and the rest of the crew on the same page, especially when shooting the scenes that haven't been storyboarded. Now, a storyboard is simply, if you have a question, it's simply an illustration or images displayed in sequence for the purpose of pre-visualization of the picture or of your documentary. Animation, motion picture, you can use it for anything, but it helps you visualize your film. So here are some examples of what a shot list look like in a storyboard. And as you can see in your shot list, you have the shot number, which is when you're gonna, what order you're gonna shoot it in, how long the shot is gonna last when you're filming, what type of shot it is. These initials, LS, MU, MCU, MS, that's those are just acronyms for medium shots, close up, and we'll get into that in more detail. It gives you your angles, your camera movement, and what's taking place in that action. So it really organizes the shot for you when you're doing your film. Your storyboard is just going to simply be a pictures that's showing you, again, what that information is going to look like on the camera or through the camera. Okay, so thank you guys for attending. I'm going to stay connected with you here on CSTEM Break. So please feel free to message me with any questions that you have. I know this was a little speedy, but I will put more information up for you guys to go over.
Hello everyone and welcome to the CSTEM Photography Challenge for 2014-2015. My name is Alicia Garcia and I am with the Houston Center for Photography. And I cannot wait to talk to you guys about what our challenge is this year. Our challenge, or should I say problem, that we are going to try and solve and create solutions for has to deal with wind power. So the issue we have is that wind power and turbines that we see in rural areas, especially in the West Texas area, it's in fact exactly what they are. They're not anywhere near cities. It's not modern and in the middle of nowhere. So our solution is, can we help modernize wind turbines and have them a little more accessible to, and have them incorporated into buildings such as buildings, bridges, and light posts. I've highlighted those key buzzwords of wind power, turbines, and to modernize turbines. The idea it's not like the Wild West, it's not somewhere out in the open, that we think about these in our contemporary landscape. The challenge for the students on the solution end is that our students will create a close-up, repeat, close-up, it's important that that is the key term for your students, close-up photography of an area where modernized wind turbines can be placed to generate clean and renewable energy. Each school's photo challenge must be enclosed in a frame created and designed by students, and these next few sentences are really important, by students using recycled and or reused materials only. This is 100% fabricated by your students. So recycled and or reused materials only. And within the entire fabrication of your frame, the frame cannot exceed 8 by 10. The photo itself cannot exceed 8 by 10 inches either. This is a very perplexing and confusing regulation that we have. So I will delve into that a little bit during this session, and in the future sessions we will be heavily talking about construction of your frame, because a lot of people have a hard time or encounter special questions with their students along the way. But besides that, we have the visual component of a frame. The other component that we need is that you need to have a written portion of information alongside your photograph. It's beautifully framed. You spent so much time on it to let the viewer know what we're looking at. As people walk around at the George R. Brown, they need to know what we're working with. And it needs to be handwritten or typed. So I would really, as teachers, make that judgment based off of if the handwriting is easily read, sure. And if it maybe we can try and type that out, especially if you have older elementary students, that this is easily done for them. And that must be done in 12-point font and double spaced. That way it is easy and quick to read. But this is a blown up version of the rubric, where I'm only going to talk about a few areas of this rubric for how the photos will be scored. And this is just preliminary information, and throughout the challenge we will be a lot more specific with what we're working with. So our scoring rubric is from levels, I should say, points of 0 to 3. 3 being exemplary and 0 being unacceptable. So the numbers of criteria I would like to talk about is the very first one, number 1, and then number 3. Number 1, the criteria is the photo must be clearly visible and taken with precision. Now, in our day and age, we have lots of people that will say a photograph is really good, and they took one photo to make that photograph happen. In all actuality, if we look at the rubric system, you can be exemplary, recognized, and acceptable, points of 3, 2, and 1, and they all have a clear image. So having a good image is not the only thing that will help your students understand what makes an exceptional photograph. We want the photographs to be interesting, and above all, if you look at the details in each of these point systems, it says that they are using the use of color. So at no point should any photograph that's turned in be in black and white, because that actually would automatically constitute you to be 0, which poor use of color and dull. Although black and white photographs are actually not dull, it is a poor use of color because it lacks color entirely. So understand that we need sharp photos, they need to be intriguing, and they have to have really good color. So if you guys notice that we just went through daylight savings time, which some people consider to be the best day of the year because you get an extra hour of sleep. The other thing that we need to keep in mind is that it gets darker sooner. So if your students want to go take photos outside right now, photographically, they don't have as much time after school. So be aware of that and understand that we have to push a lot of awareness of, hey, you really only have until maybe 4 or 5 o'clock if you want a daylight photograph. And let's now jump to number 3 on the rubric, and that is the frame. So we get lots and lots of questions about the frame all the time. And what makes a 0, what makes a 3? If you have an exceptional frame, there's no doubt about what we're looking at. It is the right size, and that goes without saying. And 100% of the frame is made of reused and or recycled material. So I like it says reused because that means repurposed, and we're not just thinking about standard recycled materials. But number 2, we have approximately 75% of the frame is being used. All right, so not quite 100%, maybe we fell short a little bit, so you get scored with a 2. Number 1, or say point 1, approximately 50% of the frame was made correct materials. So this example is one I think that could easily happen to any of your students. And that example is if somebody went and was very lost and bought a picture frame and said, in this picture frame, I'm going to find some material and glue it on top and just cover it with, let's say, they covered it in leaves because that frame was about turbines being in a park. Well, that's really like kind of repurposing already photographic material that you probably went and bought at the store. We want you to really create your frame. So 50%, we're going to give you, really half-hearted on that. But it's still better than a 0. And a 0, it means it doesn't matter how much of the percent of the materials you did. If the frame is not the correct size, it's a 0. And that's the hardest part. If you have a student that's really excited and they make an 11 by 14 frame or even larger because they have the concept that bigger means better, we also want to have the concept that following the rules means that you listen. So bigger doesn't mean better, it means can you follow the rules? 8 by 10 is what we want, and even if it was a gigantic, beautifully constructed frame, 100% recycled and reused materials, if it's not 8 by 10, you're still getting a 0. And that's, I think, the hardest one for students that try really hard, and they're the students that want to do more. So having this clearly laid out will be very beneficial for your students. But I often get asked really simply questions like, what's the difference between black and white and color? What's the difference between different camera angles? So we can take a hint from cinema, take a hint from photography, and we'll talk about camera angles right now. Because close-up photography is going to be differently described to your students than if we were walking around taking photos of people, because we're taking photos of locations. So a close-up shot in this is a certain feature or part of the subject that takes up most of the frame. So I can tell that this is a boy, he's outside, and it's a close-up of his head. Not to be confused with what we call an extreme close-up. And please don't confuse the two, because extreme close-ups can be quite often confused for close-up framing of photography. And when we're dealing with beautiful exterior landscapes, things of Houston or surrounding areas of Houston, the challenge could be thrown off course if people get more interested of the small things on the ground, or something that's beautifully colored and we have no clue where this photo is being taken. Like, I cannot tell you right now where this boy is. Just like in the previous photo, I know that he's outside. So having some context and letting me know, because you're doing a close-up, not an extreme close-up, is extremely beneficial. And although, like we said, color is everything, although we can get some really gorgeous skies, and like downtown Houston could be a place for wind turbines. This is entirely just an example. We said, what if we could put them on bridges, buildings, light posts? This is a great idea, but the access to actually getting to a top of a building is actually what your student would need to do. This is what we call a wide angle shot. It is in no way a close-up of any of those buildings. So whether it's nighttime or daytime, although the color is great, it can be a really sharp, beautiful photograph, you have to also keep in mind if it's a close-up or not. And that one is, teachers, you will be the editing, little scrutinizing eyes saying, you know, maybe we should go back and take some more photos. Think I could do a little bit better of getting closer to your subject. And that's where you need to step in and just say, these are great photographs, we just need to get closer. And then they'll probably come back and you'll say, hey, maybe not so close. It's going to be a give and take this entire project. And so as we briefly touch on the frame, if I look at this frame, you can call it yellow, yellow ochre, gold. Let's talk about 8x10. Where a lot of people get tripped up with 8x10 or 11x14 like that we had last year was that people said, I don't quite understand where the measurement begins. Is it 8x10 where the glass of a photograph, a standard frame would be? Or is it 8x10 for the exterior dimensions of the frame? Because this is constructed, I'm going to say the exterior edge, so the far left and far right of this photograph that we're looking at right now, the outer dimension needs to be 8x10. And right now, if you go into your house, you look at any other picture frame, I have some on my wall in my office, 8x10 frames are really 8x10 for the pane of glass that's on top of your photograph. So where it gets confusing is you really can't repurpose a traditional frame because the frame and the photograph have to max out at 8x10 completely blueprint, footprint measurements. So any of you that want to stack up, we stacked up all of our competitions photos, they should all be identically 8x10 on the outer edges. Now, when people get confused, we're going to talk about it in the future, is 8x10 is the maximum size for the frame. Your photo's maximum size is 8x10. If you want to make a smaller photograph, fine. The frame still has to be 8x10. And that's where creativity comes into the mix. But some of your students might get a little sidetracked when thinking creatively about, like, where do I find my recycled materials? We don't exclusively have to look in recycling bins or just think that it's cardboard and paper. Those are the two most easily recycled materials that go through most children's heads, along with plastic. So sometimes using the word recycled isn't really a strong way to think about our work. Maybe we should, again, think about it with different buzzwords that are in everyday speak. And so I really like, and I used this slide last year, the idea of recycling versus upcycling. So recycling is those standard products that we can go to a recycling place, drop those off, and so forth. Upcycling is all sorts of things. It's repurposing and giving a new life to materials whose life was not that. So if I cut up a soda bottle, like 2-liter bottles, I can make them into holders for plants. If I cut up a pair of jeans, I can make quilt squares. Upcycling is giving that whatever original material you are using a new life and a new purpose. And the possibilities should be endless about what our students can go through. Of course, please be careful and make sure that they don't pick anything that could endanger them, nothing that's extremely sharp, because we are dealing with elementary school. So I hope that a lot of that discussion is done by parents, but if something does end up in school, please be very aware that we are entirely concerned with our students' safety and to keep that as a priority. So right now, I encourage you to ask any questions. I'm sure we'll have some about photo frames and color, sharpness, whatever technical aspects you need to ask. We will do that right now at CSTEM break. And however many or few questions you have this round, we'll get them answered. And you can always email me at alicia.garcia@gmail.com. Thank you.